Good morning, guys. So I'm making you a video today about we are going to be doing angle of depression and angles of elevation, and we're going to be just doing word problems with that. It's basically just knowing where to put the angle, and then the rest is just the basic trigonometry that we've been doing. Okay, so an angle of depression, I like for you to think. So for example, here's an example of an angle of depression is when you could think of coming from the top and depressing downward. Okay, an angle of elevation is like coming from the volume from the bottom here and elevating upward. Okay, so depressing down from the top or elevating upward from the bottom. Okay, so let me show you some examples. So sometimes they're going to be nice and give you a picture. Sometimes it's not going to be nice and you're going to have to figure out your own picture. So I'm going to show you an example of each. So from a boulder 60 meters from the base of a tower, the angle of elevation to the top of the tower is 24 degrees. How tall is the tower? Okay, so from a boulder 60 meters from the base of a tower. So again, think about what it would look like in real life. Here's a little tower, right? If you want to draw that, I don't know, that's a tower, right? The boulder is 60 meters from the base. So boulder beyond the floor. We can make a big giant boulder here. So from the base of the tower to the boulder is 60 meters, okay? And then what else does it say? The angle of elevation to the top of the tower is 24 degrees. How tall is the tower? So angle of elevation. So remember, you start from the bottom and you elevate upward. So the angle of elevation to the top of the tower, from here to the top of the tower, right? This angle right in here, the angle of elevation, okay, is this, okay? So you can call that X or theta, whatever you want to call it, okay? How tall is the tower? So they want to know, oh, I'm sorry. This says 24 degrees. I don't know why I'm putting theta. 24 degrees it says, okay? How tall is the tower? So they want to know this leg here, right? So the boulder is 60 meters from the base of the tower. The angle of elevation to the top of the tower is 24 degrees. How tall is the tower? All right, so that's what your triangle should look like. Then you're just going to use trig. Which function am I going to use? Well, I have an opposite that I need, and I have an adjacent. So opposite and adjacent, I'm going to do the tangent of 24 degrees equals opposite over adjacent, and then we're going to solve for x, right? So I'm going to multiply by 60, right? Multiply by 60, multiply by 60. So x equals 60, make sure you're in degrees, 60 times the tangent of 24 degrees, and it's going to give you about 26.7 meters. Okay, we can round to, let's do 26.7. Okay, so that's an example of angle of elevation. Okay, start from the bottom and you elevate upward. Let me show you another one. Here's an angle of depression. On a windy day, a 90-foot, so here they gave you a picture for you, okay? A windy day, a 90-foot rope tightly secures a hot air balloon to a stake in the ground. All right, so here's a hot air balloon flying in the sky. The stake in the ground would be here, right? The rope that's securing this from the stake to the balloon is 90 feet. That's why the 90 is there, okay? From the balloon, the angle of depression to the stake is 62 degrees. So remember, the angle of elevation is, you're starting from the top and you're elevating downward, okay? So the angle of elevation is here, from the from the balloon to the stake, right? Okay, so you could think of it this way. The angle of depression, did I say angle of elevation before? The angle of depression is always on the outside of this like triangle here, okay? It's not in here. It's very common that you would put it in here. It is not in here. It's out here, all right? Find to the nearest foot the height of the balloon, assuming the wind to be constant. So they want to know what's this height here, right? So let me draw this for you. I should have drew this sooner here. Here's my balloon. Here's the stake. This was 90 here. And then you have your angle of depression is 62 degrees in here. And we want to know what is the height of the balloon. Okay, so here's a couple ways you can do it. You can either make a triangle here, and you know that if this is 62 degrees, this is 90. If this is x, this is also x, right? Because it's going to be the same. Or if you want to use this triangle inside here, you know, by geometry, if alternate interior angles, if this is 62 degrees, this is also 62 degrees. All right, so you could use this triangle, just know that it's going to be in here because it's alternate. So, I don't know, whichever way you want to do. You want to use this one? Let's use this one. So, if I use this one, I'm going to do the sine of 62 degrees is x over 90, right? If you use this one, it would be the same, but either way. Okay, so the sine of 62 degrees equals, opposite is x over hypotenuse is 90, right? And then I'm going to just multiply both sides by 90. So I get, let's go here in my calculator, 90 times the sine of 62 degrees. Again, make sure you're in degrees, about 79.5. Okay, so x is about 79.5. All right, so that's an example there. What else? Oh, I'm going to be putting, this is like an old park problem. This is going to be on your upcoming test. It's parts A, B, C, and D. I might take out a certain part, but I want to see if you can figure it out on your own before I'm not going to put the answer and then have you do it, because it's not like in class where I could, show you and then you do it, because obviously then you could just watch the video and copy it. So I want to have you try it on your own, and then I'm going to review the answers with you, okay? So I'm going to give you an assignment, and I will let you know when it's due. I know spring break is coming up, so I might just give you something that will last you like a couple days for the rest of the, the next couple days before spring break. All right, let me know if you have questions. Have a good day.